Now, let's talk about oxidation reactions. Alcohols can also be oxidized. But in order to carry out these reactions, we first need to clarify some terminology. What do we mean by oxidation? So oxidation results when there is an increase in the number of carbon-oxygen bonds, or if there is a decrease in the number of carbon-hydrogen bonds. So let's look at the example here. So here I'm showing you as things progress to the right. So as we go over to the right, we are increasing the number of carbon-oxygen bonds. So let's look at these molecules. So here I have a carbon, which is bonded to a hydroxyl group. And currently I have 3 carbon-hydrogen bonds and 1 carbon-oxygen bond. If I oxidize this molecule, that means I'm going to increase the number of carbon-oxygen bonds. So I can do that by removing, I'm going to do this in red, by removing 1 H bonded to that oxygen. I'm also going to remove an H that's bonded to this carbon, so that now I can open up room to create a double bond between the carbon and the oxygen. When I do that, I have increased the number of carbon-oxygen bonds by 1. Previously, I had just 1 carbon-oxygen bond. Now I have 2 present in this double bond. And I have also decreased the number of carbon-hydrogen bonds. Before I had 3 carbon-hydrogen bonds. Now I only have 2. So this is considered oxidation. Now I can further oxidize this molecule. So far, this group is called an aldehyde. So I have gone from an alcohol to an aldehyde. And now this aldehyde can be further oxidized by adding an oxygen here, a carbon-oxygen bond here. Okay, so I can remove this hydrogen if it's present and add an OH. So when I do that, you can see that I've increased the number of carbon-oxygen bonds. I now have 3 carbon-oxygen bonds. And now I have also decreased the number of carbon-hydrogen bonds. And what I have produced is what we call a carboxylic acid. So it turns out that alcohols can be oxidized into aldehydes and then further oxidized into carboxylic acids. But this is going to depend on the availability of hydrogens in your starting alcohol. So we have to be able to understand what our starting alcohol is before we can carry out those reactions. So let's talk about how we classify alcohols. Alcohols can be classified as primary, secondary, or tertiary. So first, locate the carbon that bears your hydroxyl group. And then if that carbon is bonded to one other carbon, we call that a primary alcohol. If that carbon is bonded to 2 other carbons, we call that a secondary. And lastly, if that carbon is bonded to 3 other carbons, we call that a tertiary alcohol. Let's look at what that looks like in the context of a full molecule. So here, first, again, locate the carbon that bears your hydroxyl group, and then look at how many carbons that carbon is bonded to. This one is bonded to just 1 other carbon, which is why we call this a primary. Now locate the carbon bearing this other hydroxyl group here, and then we count 1, 2, 3 carbons. That carbon is bonded to 3 other carbons, so this is going to be a tertiary alcohol. If we look here, this is the carbon bearing that hydroxyl group. So we look 1, 2, that carbon is bonded to 2 other carbons. This is why this is a secondary alcohol. Okay. So now that we understand what oxidation means and how we can classify alcohols, let's look at a reaction of a primary alcohol. So here's my primary alcohol. Again, it's primary because the carbon bearing my hydroxyl group is bonded to just 1 other carbon. So this means that I have 2 hydrogens available here in this carbon. So in my first oxidation step, I'm going to remove one of the hydrogens bonded to the oxygen and one of my hydrogens bonded to my carbon. And then when I do that, I can now create a double bond here between the carbon and the oxygen, which is how we get this aldehyde. Now, because I started with a primary alcohol, I have a remaining hydrogen that is present here in this aldehyde. So that means I can carry out another oxidation step. This is going to look a little different from the first one, but it's the same idea in that I am going to increase the number of carbon-oxygen bonds. So then I can replace this hydrogen with this OH group to give me a carboxylic acid. So what this means is that primary alcohols can be oxidized into an aldehyde, which is your intermediate, and then it can be further oxidized into a carboxylic acid. Let's look at an example of that. Here we have ethanol. Ethanol is a primary alcohol. And so when we oxidize it the first time around, we remove these hydrogens, and that will create acetaldehyde. And again, here is our aldehyde group. And then this aldehyde group can be further oxidized into a carboxylic acid, where this hydrogen here is replaced with an OH. Okay? And here is your carboxylic acid functional group. Let's look at secondary alcohols. Okay? So we can oxidize secondary alcohols as follows. Again, first locate the carbon that bears your hydroxyl group, and we can see it's secondary because there's a carbon chain in that direction and a carbon in this other direction. We also identified that there is at least one hydrogen available here. So this is important because we can remove this hydrogen and remove this hydrogen, and that's what allows us to create a double bond between this carbon and this oxygen, which is an oxidation. When we do that, we get this ketone, this type of structure, because we had an R here and an R there, and those are the two R groups shown here. So because there was a hydrogen available, we were able to remove it to create this double bond, but we cannot continue to oxidize this molecule because there are no hydrogens left here to oxidize. So that means that secondary alcohols can only be oxidized up to a ketone. It cannot be oxidized further. Here's an example of that. 2-propanol is an example of a secondary alcohol because there's one carbon group bound to that carbon, and here's the second one. Okay. But we still have this hydrogen we can remove, that hydrogen we can remove, and we can make this double bonded carbon-oxygen bond. Okay. And this is going to be what we call acetone, which is a type of ketone. Okay. And our ketone is, again, this carbon double bonded to an oxygen, and on each side, we have these carbons. Okay. So that's the definition of a ketone. Let's look at our tertiary alcohol. Tertiary alcohols cannot be oxidized. Why is this? Well, first locate the carbon that bears your hydroxyl group. And because it's a tertiary alcohol, you have a carbon on that side, a carbon on this side, and a carbon here. So what this means is that there are no hydrogens on this carbon that I can remove in order to create a double bond between this carbon and the oxygen. This is not possible. I'm not able to do that. And for this reason, there is no reaction for tertiary alcohols. So let's put that into practice. Okay, so we're going to draw the product forms when each alcohol is oxidized with K2Cr2O7. This is potassium permanganate. This is a common oxidizing agent. All right, so let's start with our first example here. The first thing you want to do is identify the carbon that bears your hydroxyl group, which is this one. Okay. Now we're going to determine whether this is a primary, secondary, or tertiary alcohol, because this will let us know whether we're going to make a ketone, a carboxylic acid, or no reaction. So this carbon here, it is bonded to one other carbon. So that means this is a primary alcohol. So this is a primary alcohol. So that means that I have two hydrogens. Oops. Yeah, two hydrogens here. So my first oxidation step, this notation here is just a generic term for some oxidizing agent. In this case, it's going to be this species here. But it doesn't really matter as long as I let you know that this is an oxidizing agent. So what's going to happen is I can remove this hydrogen and then remove one of the hydrogens here so that I can create a double bond there, which will leave me with an aldehyde and then the remaining hydrogen here. So because I still have a hydrogen on this carbon here, I still have a hydrogen, that means I can oxidize this further. And now I'm going to do that by adding an oxygen to that group there. So we're going to do this. And now I'm going to remove this hydrogen and add an OH group. And this is how we get a carboxylic acid from a primary alcohol. Let's look at the second example. Locate the carbon that bears your hydroxyl group. Now let's see how many carbons are bonded to this one. 1 and 2. So that means this is a secondary alcohol. So this carbon here bears one hydrogen group. So this means I can remove this hydrogen, remove that hydrogen. And what will result is a double bonded carbon oxygen here. So there's a carbon oxygen double bond that I have created. So I have carried out an oxidation step. Now at this point, this carbon here does not have any more hydrogens that I can oxidize. So this means that I'm done here. So a secondary alcohol will give you a ketone. This is a ketone, and this here is a carboxylic acid. This intermediate step here, this is an aldehyde. All right, let's look at this last example here. Again, let's locate the carbon that bears our hydroxyl group, which is this one here. And then we're going to look at how many carbons are bonded to this. 1, 2, and 3. So this is going to be a tertiary alcohol. So what this means is that there is no hydrogen present here. There's no hydrogen there. Okay. So I cannot remove a hydrogen from this carbon to remove the hydrogen that's bonded to this oxygen to create a double bond, like I did in this example here. Okay, there's no hydrogen here. So because there's no hydrogen there, I cannot make a double bond between this carbon and this oxygen. That means there is no reaction.